So today we're going to be getting through our next section of Module 14, which is talking about comparing functions. And really, this is just a way of saying, what if we're given a function in one form and a function in another form? How can we compare them? So I really want you to kind of be thinking about when we have fractions and we're comparing fractions, what do? We get a common denominator, and then we can compare them. When we're comparing functions, we want to basically get to a common form so that both functions are written in the same way, and then we can compare the different parts of the functions. Let's take a look at what this can look like. I'm in your book on page 431 if you want to follow along. And in this case, Josh and Maggie are both buying music files from different services. The monthly cost for the songs are linear. That's good. That means that they can both be written in y equals mx plus b form, okay? And this is a win because now we know what we can compare. The cost of Josh's service is already given to us. The cost of Maggie's service is in this table. So really what we need to do is be able to write an equation that represents Maggie's service, because then we can compare these two equations with each other. We know how to do this. This is review from last week. We're going to choose any two ordered pairs from the table to calculate their slope, m, okay? And in this case, they want us to go ahead and use these points, which is not a big deal. We'll go ahead and plug those in. 9.90 minus this y means we're going to do x minus 5. When we calculate those, we've got 4.95 over 5, which simplifies to 0.99. And again, that's our slope. That's our rate of change, okay? Then we're going to use the slope and any point up here in the table to calculate what the y-intercept is. We worked on this a lot last week. M, we know, is 0.99. We're going to multiply it by our value of x. Because we used a 4.95 for y, our value for x is 5. And then the problem tells us to multiply these things together. Okay? When I multiply those things together and then subtract on both sides, I actually end up with b is equal to 0. I'm not going to take the time to do those calculations because, again, this is review from last week. Then I'm going to write that equation in slope-intercept form, which is y equals 0.99x plus 0, or simply y equals 0.99x. Okay, well now it's really easy to see. We've got two different services. We can compare these really easily with each other, okay? And then it asks us which service is cheaper. Now if we stop here for a second, this is saying that Josh's service costs 50 cents, 50 cents per song. Maggie's service costs 99 cents per song. It seems like Maggie might be more expensive, but notice Josh also has to pay this initial $10 fee, meaning no matter how many songs he downloads, he's got to pay 10 bucks. Once he's paid the 10 bucks, each song is only 50 cents. Maggie doesn't have an upfront fee, but she does have to pay 99 cents per song, okay? So if I want to know which service is cheaper when we've got 30 songs that are downloaded, we're going to plug in 30 for the x. Once we plug in 30 for both of these x's and simplify our equations, we find the cost for both of these situations. In other words, if Josh buys 30 songs, he's going to pay 25 cents. If Maggie buys 30 songs, she is going to pay $29.70, which means Josh's service is cheaper. We want to keep those things in mind so that we can compare the different costs or which one's going to be cheaper or more expensive over the long term. Okay, let's flip to the next page and kind of take a look and see what happens when they're compared to us, possibly in a different situation. This is similar to the front. You've got Quentin is choosing between buying books at the bookstore or buying the online version, okay? And they're going to tell us that the cost for ordering books ordering books online is given in this equation, but the cost for buying books at the bookstore is showing the table. So again, in order to be able to answer this question, you're going to have to write these both in the y-intercept form, just like we did on the front. Now, sometimes instead of giving us the equation in a table, they're going to give us a table and a graph. All right. Now, again, we are looking for this key information. We are looking for the y equals mx plus b information. Okay. On our graph, it's pretty easy to see if we want y equals mx plus b. It's very easy to see that the b is 0. And then we've got this slope kind of going right up towards the middle of it. If I come over here to Morgan's typing test, I don't know what her slope is yet, but I can easily calculate it. 60 minus 30 is 30. 4 minus 2 is 2. And 30 divided by 2 is 15. So she's got 15 words per minute. Okay? If we come over here to Brian, we can calculate his words per minute. It looks like here's our next point of intersection. It's increasing at 60 over 3. Well, 60 over 3 simplifies to 20 words per minute. And clearly, once we have those rates, those slopes, we can see which student types more correct words per minute. Obviously, it is Brian. He types 5 words per minute more than Morgan. Okay, so really when we're looking at these things, again, we're looking for these rates of change or these speeds that these things are happening. And the way to do that is to always come back to how can I find those rates? How can I write this information in the y equals mx plus b form? And then how can I compare these things together? Okay. So the last thing I want to take a look at is over here on page 434, and we're down here on the guided practice. In this case, they're giving us an equation and a graph, kind of like in the last one. We're going to describe the plan that's shown on the graph. We're looking at different tutoring fees. The first tutoring fee, Plan 1, students pay just $15 per hour. So if I was going to translate that to my y equals mx plus b form, we've got that students are paying $15 per hour. Now what's interesting over here is we've got a different tutoring plan over here with Plan 2. I'm going to look for that rate of change first. I've got 40 and 0, and my next point is 50 and 2. Well, 50 minus 40 and 2 minus 1 gives me 10 over 2, which is 5. So for this one, we've got y is equal to 5x. But what's really interesting here is notice up here, our y-intercept is 0. That means you pay no money if you have no tutoring. But on this tutoring fee, notice if you have no tutoring, you are still starting out paying $40. Okay? So this plan that's shown on the graph, it starts with a payment of $40. And then it increases by $5 per hour, okay? If we're gonna sketch the graph showing $15 per hour, which is our situation up here, we're starting here at the 0, but notice we go 15 per 1 hour, okay? We're up here to 30 per 2 hours, 45 per 3 hours, 60 per 4 hours, and then 75 per 5 hours. So what's really interesting here is at one point they cross over and then they surpass each other. Well, what does this intersection point mean? Well, they both have in common that at 4 hours, it's going to cost $60. So 4 hours is $60 of tutoring. However, when I come out here to 10 hours, then it's going to be cheaper to have the plan 2. Okay? I can prove this algebraically by plugging in 10 to both of my equations. y equals 15 times 10 would be $150 for 10 hours of tutoring. But y equals 5 times 10 plus 40 is going to be 50 plus 40, which would be $90 for 10 hours of tutoring. Okay? When we look at if the cost and time are proportional or non-proportional, then again, in this plan right here, plan 1, it's proportional because it starts at 0. But plan 2 is non-proportional because it starts at the y-intercept of 40. So when you're using tables and graphs and equations to compare functions, why do you find the equations for table and graphs? It's because you want to be able to compare the slope or the rate of change in both functions. Until you get kind of that common setup, then you're not going to be able to compare the information. Okay, you guys will do great with this. If you want to watch a little bit more about this, head on over to my HRW. They've got a great support video for Module 14.3.